Good evening, my name is Jan Correa, student number 629335590. This is the Transportation Engineering Pavement and Geometric Design project for a road design. So the project scope. The problem statement is to upgrade a gravel road or a road that has exceeded its lifespan to a standard 2-lane road, 1 lane in each direction, and to use a commercially available geometric design software to generate the final alignment of the design. The specific design criteria was given in accordance with TRH4 and TRH17. Scope and limitations. The focus of the project is to design the road using a design software known as Civil Designer or any other available road design program. The roads must be designed to vertical levels in order to obtain results where the cut and fill can balance. There are areas where the assumption used, such as radius, might not be realistic. This can cause a danger in the road design. The given design criteria. So the length, it had to be between 3 to 4 kilometers long. The type was a gravel road or a road that's exceeded its lifespan, which must be a 2-lane road, 1 lane in each direction. The shape, it must contain at least 1 curve in order to do horizontal and vertical alignment, and an additional hypothetical or theoretical drainage system was to be included or at least discussed. The outputs from the project would be horizontal and vertical curves, an Excel spreadsheet demonstrating this, a mass hall diagram produced from the software program, a hypothetical drainage system. Okay, using Civil 3D, which is an AutoCAD software, the methodology was that a DWG file was provided by my mentor. It was for the Lime Pride Lifestyle Estate. Using this file, there was the cadastral, which was already provided, as well as the survey points, which was demonstrated as spot heights. Using these points, the procedure was to create a surface. The surface then can create the natural ground level, which produces contour lines through triangulation. Using this, you can plot all the contours for that area from the spot heights. But in order to get this, these contours into Civil Designer, you would need to extract the contours from the surface created and explode them to create polylines with heights. Then you need to save this the polylines as a DXF file, which can be imported into Civil Designer. I also saved the cadastral as a DXF file so that when using Civil Designer, the ease of reference is more clear. Okay, the background shows the actual project from Civil Designer. So you open up the DXF files created from AutoCAD for Civil 3D into Civil Designer. You paste the contours and cadastrals onto one drawing and save the drawing. You also create a DTM file at this point. You then triangulate the polylines to create the contours back into Civil Designer. You begin the actual designing process from this point as all the data is present. So you begin by plotting the geometric point of intersections for the horizontal alignment. You then follow the procedures to ensure that all necessary curves and radiuses are in place. Then you begin to generate the vertical alignment using the same method. You can use a graphical method, a geometric method, or you can use a spreadsheet method. Then you perform the procedures to determine the cumulative unadjusted cut and fill volumes. Once you receive these values, you will be able to verify if the alignment works, because the cut and fill values will either balance or not. If they don't balance, you would need to perform this procedures in the vertical alignment again by adjusting the point of intersections in order to get either increase the amount of cut or reduce the amount of cut or fill, whichever way to get them to equal. You also need to ensure that the radiuses are in place and that you can also check then on the spreadsheet to ensure that the heights and elevations are correct. From my drawing, the final total cut value was 59,516 and 79 cubic meters. The total fill was 59,512 cubic meters. The difference comes around to about 4 cubic meters, which I deemed suitable. The only problem I did notice was that the amount of cut and fill was an extremely large number. After discussing with my mentor, it was seen that although the values balance, the volumes balance, the actual design is impractical because it is quite a large number. So instead of following a gentle slope, which is what I use, the road would need to follow more on the natural ground level instead of the design level. So my slope was more gentle. We would need to increase the slope so that it follows the ground level. Although this area is quite steep, it would be up to the designer or developer to decide, do they require a gentle gradient or would they use steeper slopes for the road. For the Excel calculations, I used the point of intersection 9. It had a easier curve, as explained later on in the video. So the input data required would be the intersection angle, the degree of curvature, as well as the point of intersection. So at this point of intersection, it is 2,550 meters. So the output result would be the radius, and all the formulas are given on the right-hand side there of how it formulates in Excel, so that any future values that are changed will be automatically generated. So the radius came to about 110 meters, which is the minimum required. The tangent is 29.411 meters. The length is 57.471. At this point is when I noticed that the minimum length of a road should be 300 meters at a curve of 110 for a design speed of 60 kilometers. This is way below the minimum value. Even though some cases you can use 150 meters, this is still below that extreme case. This is when I noticed that the design is incorrect and that the roads I've chosen fall out of the scope of the project, as I chose 2 roads that intersect instead of one long road. The design criteria is in fact incorrect, because the speeds to stop and start would at that intersection would change, which would then adjust the curves and the radius. Although I noticed this, I still proceeded with the project to ensure that at the time it was already too late because all the work had already been done. Although I can only specify where the project went wrong, but in practical terms at this point a redesign would have to take place to ensure either the roads need to change or the alignments need to change, and to see, because the way the design formulated was it went through the estate, which is not practical. So in a practical sense this road would not be used, but for designing purposes and explaining purposes it would suffice. The external length of this particular horizontal curve was 3.872 meters. The chord length came to 56.817 meters. Middle ordinate, beginning of curve change and end of curve change as seen on the screen. The formulas used in the standards are given on the right. Again, with the vertical curves, although the vertical curves work out, the gradients were just quite steep. So for designing purposes, I used a approaching gradient of 4% and a leaving gradient of 5%. The curve length was 190, the chainage was 2250, and the elevation was at 1401. This then outputted the results as follows. So the beginning of vertical curve is 2155, end of vertical curve was 2345, and the elevation at the beginning would be 1397.2 meters. The end of vertical curve elevation is 1,396.25 meters. And then the highest point chainage was at 2,239.444 meters chainage at an elevation of 1,398.889 meters. Okay, for the drainage, only a theoretical or hypothetical design was needed or discussion. I used the basic standards from GRH, which is Johannesburg standards, to just display the road reserve for a 10.5 meter road. And in this standard, it shows the basic drainage system of a road, where they used a concrete curb inlet through the stormwater system. However, during the designing process, I used a road template, and the road template then showed that the super elevation is 2% both sides, left and right. I used a Sandroll 300 V drain on both sides of the road. On the left side, which is closest to the border of the Lion Pride Lifestyle Estate, I used inserted a sidewalk for ease of access for the community, or just for a more of a lifestyle usage. I also added the 4-meter verge, as the road reserve is set out for 25 meters to 36 meters, which can be used for future lanes or future bicycle lanes or pedestrian walking areas. My mentor for this project was Louis Fourie. He's registered with the Engineering Council of South Africa. His registration number is 2018-0118. He works at Cosmopolitan Projects as an engineer. His comments from the 24th of April were that the roads chosen were turned out to be difficult to perform the tasks needed, as there's an intersection instead of one single road. Although the above mentioned was identified, the time in which to rectify this was not enough. The effort needed to obtain and investigate a new road was not possible at the time, as we could not find more contours that would give me a straight line. Therefore, we both decided that instead of redoing it, we would work as if the two roads, instead of intersected and created a four-way stop, would be one constant road. Although this provided further challenges, as although the curves were set to, at a design speed of 60 kilometers an hour, were set to 110 meter radius, the minimum length of these radiuses could not be met, and therefore the design did not work out. The cut and fill volumes, yes, they did work out, or they did equal. However, he pointed out that it's impractical to have such a high value, and that instead of focusing on the slope of the road, I should have focused more on going with the natural ground level in order to save costs and labor costs and practicality, as the amount of effort needed to excavate the material and then place it somewhere else would be infeasible. His final remark on the 5th of May was that a single road should have been designed for so I should have picked a different road or simple road for designing purposes of the project. Although this was recommended based on the outcome, the processes I followed he deemed were sufficient to show my talents. If the time allowed it, he would have liked for me to perform the single road, as I can get exposure into the designing process of transportation engineering, but he felt that I did understand the topic at hand. It was just the execution that was a problem. Okay, based on the results obtained, it's clear that the cut and fill do balance, or almost balance, as there's a 4.79 difference in cubic meters. It would have been better to have it under 2, but this is still within range. The high cut and fill values were in theoretical terms correct, however in practical terms the cost and energy spent on removing and recompacting the soil would be much higher and infeasible. Therefore it would be necessary to, instead of focus on a gentle and uniform gradient, I should follow the natural ground level and just ensure that the slopes and the gradients in the vertical curve are still sufficient and safe. Once again, my name is Jan Correa, student number 629-33590. This is my transportation engineering project.